So if I did this one, the first thing I would do is I would divide both sides by 2, right?
No.
Actually, no.
No. That's why that first answer is 100% wrong. I said sine x never equals 1/4. That's not how you do this. This is breaking math. You cannot divide by 2. Gone. Yeah.
Oh, I was going to tell you how to do it.
Okay, how would I do it?
Oh, look for, see where sine equals -1/2.
Yes. Either you think of this as just being like a y in place of this 2x. However you do this, the question is, when does sine, regular sine, equal -1/2? And on our unit circle, it equals -1/2 in 2 locations. Well, sine is negative in quadrants 3 and 4 because it's positive in 1 and 2, because we have all students take calculus. I'll keep saying that over and over and over. You good? Okay. So we should figure out where it's -1/2. Well, it's going to equal -1/2 here and here, which would end up being 7 pi over 6 and 11 pi over 6. If this was just a regular problem, we would just have this equals 7 pi over 6 plus 2 pi n, and we'd also have another answer is 11 pi over 6 plus 2 pi n. This would work if there was just an x here instead of 2x. But there's a 2x there. So I'm not asking what x equals, I'm asking what 2x equals right now. I'm asking what does 2x equal, so we would put 2 x's in for these. Which means I would divide everything by 2, which is the same thing as multiplying everything by 1/2. If I do that to everything, we're going to end up having x equals 7 pi over 12 plus pi n. And we'll have x equals 11 pi over 12 plus pi times n.
Wouldn't it be n, Tom? Is that pi n? It's the same thing.
It would be the same thing. You can, either order works.
You never know.
You never do
You
know.
never know until you ask.
All right. Questions on the bell work?
Can you use K instead of N?
Yes.
Because technically,
Yep.
it's not the same answer.
I tend to like K because N just gets lost in my writing. K usually stands out a little better. Yeah.
Why can you not divide by 2 again?
In the very beginning? Because this is sine of 2x. It's trapped in there. You have to undo sine first. You have to get the 2x by itself. It's kind of like, let's say I have, what would be a good example? Let's say I have 2x squared equals 4. The first thing you do here cannot be divide by 2.
Yeah, right.
You'd have to do the square first.
Right.
So in this, before I divide by 2, I have to take care of the sign first. We take care of the sign by saying, when does sine equal this? Okay. Now the sign is gone and we just have our 2 x's. Okay, that's kind of our undoing of the sign. Other questions on the bell work? And I heard there was no questions on the homework, so we can just go ahead and move on. Everyone's just like, yeah, let's move on, right? 13? 13? Let's take a peek at 13. 13 on conditional trig. B13 says, we are supposed to find the 2 times sine squared x minus 7 sine x plus 3 equals 0. I said one way to look at this is to get rid of the sine x's. We don't actually have any like terms. So picture this. Picture this as being, instead of 2 sine squared x, think of that as being 2y squared minus 7y plus 3 equals 0. They're asking the exact same question. That sine of x is our variable. The whole thing together is our variable right now. So if I was to factor 2y squared minus 7y plus 3, if I was told to factor this, and I was told it is factorable, I would just write two binomials. I would just start by writing that. Now we're just going to use little tidbits to build up what we're going to put in there. So the first thing I look at is this term that's going to go here times this term that goes here has to equal that 2y squared. So the first thing I'm looking at is, well, we need a y in both of those because y times y is y squared. And one of these has to be a 2. It's the only way that we can have that 2y squared. Now I look at the last two terms. I have this term, this term. When I multiply them together, they have to equal 3. I only can think of one with whole numbers, and that must be a 1 and a 3. Now, I'm just going to randomly put these down. Kind of unrandomly because I know the answer. But this could be 3 and this could be a 1. This could be a 1. This could be a 3. We got a 50-50 shot of having that correct. Because either way, it's going to equal it. Now, to figure out if I put them in the right places, what you're going to do is you're going to multiply your first and last term. I don't like that color because I already used it. Let's go light pink. So we're going to multiply those two, and we're going to multiply the middle ones, and we're going to add that together. So I have 2y times 3, which is 6y, plus 1y equals a positive 7y, but it's supposed to be a negative 7y. That's why I didn't put any signs on here, because that's the next thing we have to figure out. Well, 7 is good, because it does add to 7. So what I'm going to do is I'm going to go ahead and I'm going to put negative signs on both of those. Because a negative 1 times a negative 3 is a positive 3. Negative 1y minus 6y does give me my negative 7y. Now don't forget, this is really 2 sine x minus 1, and this is sine x minus 3. So now we have two possibilities. In fact, how about we rewrite them in the original thing? So we're going to either have 2y minus 1 equals 0, or we're going to have y minus 3 equals 0. But don't forget, the y is a placeholder for sine x. The old sin. And the other one would be sine x minus 3 equals 0. Now we can solve for these. Now we can get sine x isolated. So for the first one, I would add 1 to both sides, and then I would divide by 2. So that first one we're looking at where sine x equals 1/2. Once again, that's adding 1, divide by 2. Well, sine equals 1/2. Is this all solutions? Or is this just some solutions? All solutions. So this one's going to be x equals pi over 6 plus 2 pi n, or k. Or it's going to be x equals 5 pi over 6 plus 2 pi n. So that handles that first one. Our next one's actually pretty nice, because when does sine equal 3? Never. So this is does not exist. Extraneous solution. Charlie.
The first term, 2y squared, how much did it square?
2y squared. It got taken out because we factored it. Because what's 2y times y? That's where it is. It's buried in this. When you factor stuff, it should always drop a power. That's the point of factoring it. All right, more questions? That was it? Oh, yeah, Charlie. On number 11? Okay. Sure, that's a great question. That's another good question. I guess? Sure. All right, number 11. Number 11 is a lot like our bell work in the fact that we don't have just x in it. So we have 2 sine x over 2 minus 1 equals 0. Our job on problems like these are to forget about the fact that the inside parenthesis is different than just x. In fact, you can just replace it with a variable. You can put y equals. So if you wanted to, you could have put a y in for this. We could say, what if I just have a y in for that, if you want to? If I just had a y in there, we would end up just having, if I added 1 and divided by 2, Can you picture that with me? So if I added 1 divided by 2, I kind of have sine, y equals 1 over 2. So they're just asking, when does sine equal 1/2? Well, sine equals 1/2 at 2 locations, at pi over 6 and at 5 pi over 6. This would be 2 pi n plus 2 pi n. If this was a normal one that just had a normal x in here, we'd be done. But I'm not asking you what x equals right now. I'm actually asking you what x over 2 equals. So here's my advice on these. Just figure out what the sign equals and just put your equal sign. And then what goes on the left-hand side is whatever's in that parenthesis. Now we just multiply everything by 2. So that would be x equals, 2 times pi over 6 would be 2 pi over 6, which reduces to pi over 3. 2 times 2 is 4 pi n. 2 times 5 pi over 6 is 10 pi over 6, but that will reduce to 5 pi over 3. 2 times 2 is 4 pi n. And that would be your answers to that. So if it's x over 2, we just multiply both sides by 2. Charlie, do all those steps make sense?
Yeah.
I'm confused where you get the 5 pi over 3.
Do you have a question on this one, or you have a different question?
Yes.
Okay, let's go this one because I saw your hand.
The 1/2, where's that go?
Where did that go?
Yeah.
I had to ask a question. This just says,
Where did it come from? 1/2.
where does, this is where does sine equal 1/2. The 1/2 comes from when you add the 1 to this side, you would then you'd have to divide by 2. So it came from, this is being, 2x minus 1, add 1, divide by 2 kind of thing. All right, I saw some other hands up. Is it on this question? Okay. Yeah, you both did. Go ahead, you're closer.
In Canada, the same question is how you got the 5 pi over 3 equals 5 pi over 6.
How did I get
5 pi over,
Is it just because you're multiplying?
how did I get this?
Yeah.
I got this because I multiplied everything by 2.
Now you're just doing that on the top.
So I'd multiply everything by 2. When you multiply by 2, you're really doing 2 over 1.
Okay, gotcha.
It's the same thing. So the 2 goes to the top. That would go there. That would go there. These would cancel out. So I'm left with just x equals, this would be, I am missing a step because this is 10 pi over 6. I just reduced it in my head. And the other way I look at it is, if I have a 2 attached to this, the 2 and the 6 kind of cancel out, and I just get left with the 3. So show as many steps or as little steps as you need to.
Thank you.
It can. I don't actually do the multiplication. I look to see if what I'm multiplying by reduces first. So I look at the 2 and the 6 first, and 2 over 6 becomes 1/3. That can be a nice little shortcut sometimes. Shoot. All right. Yeah, Jude.
I was just going to ask where you get the 4 pi n from.
The 4 pi n? Oh, do you know where I got the 2 pi from? Maybe not, because you weren't here for this. These you have to list all solutions. So the question is list all solutions. So to give all solutions, I have to list every coterminal angle to that angle. So that's where plus 2 pi comes from. And then n says I can find as many coterminals as I want.
Okay.
Now, once that's in place, now I multiply everything by 2 because of this.
Okay.
Okay? All right, other questions? Questions going once? Going twice?
Can you do
Going 3 times?
number 6?
4 times?
That's,
Number 6? Yeah.
I just get like, I struggle when you do like a whole number like 1 and then
Don't. I think you're just overthinking it. So number 6, I think, is asking where does tangent equal 1? And I think where the problem stems from is because for sine and cosine, the ones are always on like the horizontal or the vertical. For tangent, that's not true. Look at your first quadrant. Look where tangent equals a positive 1.
Is that just at 0?
Is it? Well, look, your tangent values are your blue ones way on the outside. Look in quadrant 1.
Pi
What
over 4.
angle is that? Pi over 4. So one of these answers is going to be pi over 4. Now, tangent's weird because it's in the middle here, So it must also be a positive 1 somewhere else. 5 pi over 4. And then we just have to add our 2 pi n because I think it asks for all solutions. Don't get confused with ones, just figure out where they're at. And know that like for sine and cosine, they're on like the x or y's, but it's not the same for tangent.
So the answer to that would just be that angle square tangent is 1 plus 2 pi n.
This would actually be the whole answer right here. The x equals pi over 4 plus 2 pi n. That would be our entire answer. You need to write both of them. But we did learn yesterday that we can write this as one equation. So this would be an OR statement, because if you look at pi over 4 and 5 pi over 4, they're exactly pi units apart. So tangent had the luxury that we could have written this as pi over 4 plus pi n would also be a valid solution. Okay, are we good on the homework? And if we weren't, we're going over some more problems today. So today, we're doing some more problems, and we're also going to alter our notes just a little bit. I want this one to be 0 to 2 pi. So we're going to change this one to in radians in the interval 0 to 2 pi. Now remember, when it says 0 to 2 pi, that means we aren't doing that adding 2 pi n anymore. We're just finding the values that were on the unit circle that work for this. So if I have cosine x plus square root of 3 equals a negative cosine x, remember, cosine x is our variable right now. We need to get cosine x by itself. Well, as weird as it seems, we need to get that all on one side then. If I want cosine x on the left-hand side, I need to move everything to the left-hand side. So the first thing we're going to do is we're going to add cosine x to both sides. It will just be 0 on that side. Yep, on the other side, we're going to have 2 cosine x's plus square root of 3 equals just 0. Now, have you not got an eraser yet? Now, we're going to go ahead and we're going to subtract square root of 3 from both sides to give us 2 cosine x equals a negative square root. Wait a minute. When I subtract a square root from both sides, does that mean I should put a plus or minus by it?
Yes.
We should put a plus and minus? It's just minus. The only time you add a plus or minus is if you are the one that's taking the square root. Only if you are taking the square root do you add a plus or minus. I gave you this. Don't change it. I gave you a positive square root of 3. You had to subtract it to the other side. Do not change it to a plus or minus. Only if you are the one that took the square root of both sides. Now we divide both sides by 2, and we have cosine x equals a negative square root of 3 over 2. Now remember, this is looking for the interval. You should add these to your notes. Add this to your notes because you're going to study from this that I just want from the interval 0 to 2 pi. So that means we just look at our unit circle. We don't add 2 pi to stuff. So we just have to figure out where cosine equals a negative square root of 3 over 2. Now, I bet you any money cosine's negative in quadrant 2, and it's in quadrant 3. So I better have an angle from quadrant 2 and an angle from quadrant 3. 5 pi over 6 would be my quadrant 2 value. What would be my quadrant 3 value? 7 pi over 6. You know what the nice thing is about knowing the unit circle and knowing what quadrant things have to be in? If you know 5 pi over 6 is your answer, and I know it has to be quadrant 3 as well, one more, and I'm in that quadrant. Yeah. Because I added the interval 0 to 2 pi. If you look at, I'm going to change this very last one to be all possible values. So I'm going to scratch it off on this one. So that way we have both examples on one sheet. Yeah. This one is extracting our square root, so we need to get rid of a square root. Well, when you get rid of a square root, that has to be the last thing you do. So do not just take your square root to start off with. Let's just talk about if you did that. Don't do this. This is wrong. This is wrong. I just want to talk about the logic of it. You would have to find the square root of this entire expression, which we cannot do. You would just be stuck, which you probably don't want to do. So instead of doing that, we're going to isolate the square root first. So this needs to be isolated before I can take the square root of it. So that means I'm going to add 3 and then divide by 4. So I'm going to kind of skip a step here. So we should have sine squared theta equals a positive 3, because I'd add 3, divided by 4. Now, we should feel like I have to do something else or I did something wrong because it's 3 over 4 on our unit circle. No. So now we have to take the square root of both sides. When you take the square root of both sides, you must add a plus or minus in front of what you took the square root of. So now we're going to have sine theta equals a positive or negative. Do we know the value of square root of 3 on the top of our head? No. So we'll probably leave that as square root of 3. Do we know the square root of 4 off the top of our head? 2, so we'll change that to a 2. If you want to add that to your notes, this is really your square root of 4. Now, I'm asking for the positive and negative values of these. Where does sine equal square root of 3 over 2? I don't care if it's positive or negative. So that means we go to the first quadrant, and we should realize that pi over 3. Do I have that correct? That pi over 3 is sine equal to square root of 3 over 2? That means you should know the rest of these, because in second quadrant, it would be, would it be theta equals yeah, thank you. Nope, you're good. Theta's in place of an x. It means the same thing.
Does it matter?
No.
Okay.
What I always tell people, if you don't like dealing with theta, just change it to x's. If you don't want thetas or whatever variable I give you, you can always change the variable. You can make this a smiley face. I don't care you have smiley face equals those angles. It's just a variable. All right, so we have theta equals pi over 3. Theta equals 1 less than the denominator, which would be 2 pi over 3. Theta will equal 1 more than the denominator. That will put us in quadrant 3, which would be 4 pi over 3. Multiply the denominator by 2 and subtract 1, and you should have 5 pi over 3. It would get me all 4 quadrants where it equals square root of 3 over 2. Once again, we do not add our 2 pi n because I have to find it from the interval 0 to 2 pi. Are we good? Okay. Our next one says we're going to do the interval 0 to 360, so that probably means we're using degrees. We will not need degrees on the test, but I just like to show you that degrees still do exist. So we're going to factor the greatest common factor. Now, when we're doing anything with trig, the idea is that we get everything with trig on one side. In fact, we put everything on one side. So I'm going to subtract cosine x and put it on the other side. So I'm going to have 2 cosine theta. If you want to, you can change those to x's if it makes more sense to you. Minus cosine theta. Here is a big trig thing you need to understand. Not just trig, I guess precalc concept that's going to keep popping up from time to time. Look at your left-hand side. Every term on my left-hand side has cosine in it. This is basically 2xy minus x. So I'm actually going to put an arrow there. It helped out the other class a little bit. What was that? This is the same thing as this. This is 2 times something else minus that first something. So the same thing as 2x minus, or 2xy minus x. Everything is being multiplied. Since there's an x in everything in that yellow thing, we can pull an x out front to make this yellow one look like x times 2y minus 1 equals 0. That's factoring. It's the opposite of distributing. I'm dividing something out. If I distribute this x back in, I can get that back out. Well, we can do the same thing with cosine. We can pull both of those cosines or factor out both of those cosines, creating just a cosine theta. Bless you. And when I divide out cosine theta, we're going to be left with 2 sine theta minus cosine theta divided by cosine theta is just 1. Always a good idea to check to make sure if you just... Well, if I distribute this back in, cosine theta times this would be 2 cosine theta sine theta.
Right.
Cosine theta times 1 will get me cosine back out. So it's division. When you factor out, you divide.
Oh, okay.
So what's cosine theta divided by cosine theta? Well, it's 1. That allows me to put it out front.
Gotcha.
So factoring out, same thing as division. Factoring or distributing in is multiplication. Now I have something times something equals 0. That's our zero product property. Either the first something equals 0. In this case, we would have cosine theta equals 0. Or the second something equals 0. In this case, we would have 2 sine theta minus 1 equals 0. Does cosine theta ever equal 0 on your unit circle? Yeah. Where? Pi over 2 and 3 pi over 2. And we're using theta. I should probably change that. Theta. Now it says degrees. Pi over 2 is actually 90 degrees. Same thing as pi over 2, though. And then we should also have 270, right? That would be our 3 pi over 2. Bless you. Our next one, instead of 2 sine theta minus 1, what would I reduce that to? Sine theta equals a positive 1/2, right? Because I would add 1 and then divide by 2. So we'll have sine theta equals 1/2. I bet you sine equals 1/2 somewhere. I bet you it equals it at 30 degrees. And where else? Yep. Which would be, it'd be at 150 would be correct. Charlie, I think you went to a negative 1/2. 330 would be a negative 1/2. And what would this class be without a little bit of factoring? Since we already factored once, let's factor again. I'm going to leave these as signs for right now. I'm going to say, okay, Mr. Pabian is not going to trick me on this. This will be factorable. In order to get sine squared out, I must have a sine x and a sine x, because sine x times sine x equals sine x squared, or sine squared x. Now remember, the last one I did, I just replaced it with a variable. This I'm just going to leave it as is. It's up to you what makes more sense to you. I know that sine times sine equals sine squared. To get this 2 out, one of these must have a 2 in front of it. So I'll put a 2 here. And that really means there's a 1 here. I usually don't write the 1. But 2 times 1 equals 2. Sine times sine equals sine squared. Now, the nice thing is, how many ways can you think of 2 numbers multiplying to make 1? One way, which is 1 times 1. So we know this is going to be a 1, and this is going to be a 1. That makes it easy enough. So if this was on a test, I'd probably pick something like this that kind of forces you to get it right. Now, the one smart decision you have to make is these will not be positive and positive. Because right now we'd have 2 times 1 plus the 1 times 1, which would make me a positive 3. I need to make both of these negative. That gives us 2 possibilities. Either 2 sine x minus 1 equals 0, or sine x minus 1 equals 0. If 2 sine x minus 1 equals 0, I'm going to rewrite that as sine x equals, we would add 1, divide by 2, so that would be 1/2. Well, didn't we already get those values on the other side? So let's just keep rolling. That would be 30 degrees and 150 degrees. Coolio. Our other one will just be sine x equals 1. Now, if it's sine or cosine, we're looking at our vertical or horizontals for those ones. We know that's not true for tangent, but for sine and cosine, you just have to look at your verticals or your horizontals. Where does sine equal 1?
90 degrees.
At 90 degrees, straight up. Straight up there, so we're going to have x equals 90 degrees. Hey guys, how did I know not to add the plus? In this case, it'd be 360n, but that 2. How did I know not to?
It's not all real value.
It's not all real value because I give you an interval. I only give you answers that are between 0 and 360.
Wait, what about the 270 then?
I'm pretty sure that's less than 360. I'm no math teacher, but I'm pretty sure 270 is less than 360. And if you don't agree with that, we should trade money sometime. Okay. I'll give you 270, give me 360 back. We'll be good. All right. I'm going to cross out the interval. I don't know why that's funny, but it's me. It tickles me. All right. So we're going to cross out the interval. So I want all solutions. That makes this... Does this look like a problem we've done?
Yeah.
No, it looks a little more complicated. It looks kind of like one we've done. So I have no interval, so that means I need to have that 2 pi n. I need that 2 pi n in there. And that actually makes this kind of a lengthy problem. So in the beginning, it's going to be fine. What we need to realize is no matter what's in the parenthesis, we need to think of that as just being nothing. We could change it to y if we want to. So if I add square root of 3 over 2 to both sides, I kind of have sine of y equals square root of 3 over 2. In other words, I'm just asking where does sine equal square root of 3 over 2, and it should feel like you're doing something right because square root of 3 over 2 is on your unit circle. That should feel good, that we know that this is something that exists on our unit circle. I'm just going to put 2 equal signs, just floating there for right now. Where does sine equal square root of 3 over 2?
Is that a Y or
I put a y there. Whatever variable you want to put. I want you to forget about what's in there for a second. I want you to go, when does sine equal square root of 3 over 2? Pi over 3 would probably be a better answer. Pi over 6 it equals 1/2.
Oh, wait, yeah.
And then we should probably go, what is it, 2 pi over 3? Would that be another place that would work? All right, and then we'd have to have, because we're doing all solutions, we should probably have our plus 2 pi n, or 2 pi k, or 2k pi, or 2n pi, however you like writing it. Hey, if we can do this, we get a good chunk of the points. We understood that I'm just asking where sine equals this. Now, here's where we get the rest of the points.
Plug back in.
You plug this back in, the whole thing. I'm not asking when x equals this. Right now I have when does 2x plus pi over 3 equal this. So this is where we throw this kind of purpley thing back in there. So we're going to have that 2x plus pi over 3. And we're going to have that 2x plus pi over 3. And that means we need to solve for x. So this is a lot more than just multiplying by 2 or dividing by 2. This is I have to first add that pi over, or subtract that pi over 3 from both sides. Because I need to get rid of this pi over 3 from this side to get x by itself. So this first move is going to be subtracting pi over 3 from both sides. I'm going to work horizontally. Well, that's going to leave me with 2x on the left-hand side equals pi over 3 minus pi over 3 is 0. Plus 2 pi over, or 2 pi n. For the other one, when I subtract pi over 3 from both sides, the nice thing is there's already a common denominator, so I don't have to worry about that. I'm going to then have 2x equals, well, 2 pi over 3 minus 1 pi over 3 is just 1 pi over 3 left over, plus 2 pi n. Now we just divide everything by 2. So we divide everything by 2. So we're going to have x equals, what's 0 divided by 2? 0. So you can either write it or you don't have to. 2 pi n divided by 2 would just be pi n. And for this one, we divide everything by 2, and we have x equals, what's pi over 3 divided by 2?
Pi over 6.
Pi over 6. 2 pi n divided by 2 is just pi n. And that is our answer. Guys, let's look at this question real quick. If you could do that one, you could do anything the test has in store for you on these. There'll probably be like 3 problems that'll lead up to a hard one. Maybe not this hard. This is a really hard question. It can be. It can be really hard. But what I want to point out right now, I don't know if I told you guys this, or the other class, or both. This test is rather short. Just because It feels like we covered a lot, but we really didn't. We covered reciprocal values, inverses, graphs, and this. So rather than just giving you a whole bunch of the same problems, we kind of gave you just a small splash. So it's a shorter test. Now, that can be good or bad. The bad thing is, if you don't know, and let's pretend like this is probably more likely what would be on there, something like this, maybe you have some more stuff on there. If you don't know how to do this problem, and you lose like the 4 or 5 points on there, that drops you like a grade level if you don't know how to do this. That's the problem with not having a ton of questions, because if you don't know how to do something, it immediately impacts your grade more drastically. So make sure you know every element what we're doing. Make sure you do that review that I handed out to you at some point.
Is it like a test review pretty much?
It will be a test review. All right, do we have any questions? Yeah. 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 Okay, I can come over there and help you. All right,